Hello, my name is Landon Kawaje, one of the current team leads of the Velovations enterprise. Velo is a bicycle-focused enterprise composed of students dedicated to combining our love for bicycles with our engineering skills to create new components and accessories for the biking community. This year, Velovations was busy working on two different projects, the Trailblazer and Voodoo Hub teams. Both teams are sponsored task projects. To start, we'll dive into learning more about the Trailblazer team. The Trailblazer project is now in its sixth semester, with the current team including 4 members, Landon, Lauren, Preston, and Quentin. All 4 of us are mechanical engineering technology majors. The project's purpose is to provide a trailer suitable for mountain bike trail builders and their needs, as most of the trails are inaccessible by vehicle. The trailer needed to be maneuverable, durable, and easy to maintain. Most commercial trailers are designed strictly for road usage, lacking the mobility necessity for trail use. With a trailer design with trails and trail builders' needs in mind, the Trailblazer was born. The original design was carried out in the spring of 2024 with assistance from Michigan Tech faculties and staff, where the team produced a 2-wheeled, 3-foot by 4-foot steel trailer. This construction had many roadblocks along the way. After manufacturing and testing completion, the team had a list of notes for improvement. Having 2 wheels limited mobility, as the trailer would lift a wheel off the ground whenever the bike tilted. The trailer weighed 70 pounds empty, which was also too much. There was also no sort of suspension or braking system for the trailer. Utilizing this feedback, we redesigned the trailer in a way to meet the needs of the trail builders better. Using CAD software, we redesigned the trailer, making it narrower and only incorporating a single wheel into it. The tubing was changed from steel to aluminum, as well as from round to square, making it lighter and easier to manufacture. The wheel was also attached to the trailer through a rear triangle instead of cutting a section out of the trailer for it. We tested the new aluminum trailer to see how it maneuvered on the road and on the mountain bike trails. We tested it both with and without weight added to the trailer basket. After testing the trailer, we started the second phase of the new trailer design. After extensive research and discussions with MTU faculty and our advisor at General Motors, we decided to construct a surge brake system for the trailer to assist the rider. To add this brake system, we need to rebuild the rear triangle to make room for the brake caliper. The brake system is self-activated using a slider design underneath the basket of the trailer. Our team attached drawer slides to the bottom of the trailer to slide forward and back to activate the brake. We are currently building the design, with the final product expected to be showcased at the Design Expo. The future looks busy for our team, as the upcoming fall semester will consist of testing the trailer and the surge brake components. The trailer will be tested on the road and on the mountain bike trails, giving a good look into the terrain the trailer will encounter. From there, we'll reevaluate and decide if our brake system should be made permanent by welding our currently bolted system to the trailer, or if we need to do some redesigns. Overall, the testing will ensure that the trailer fits the initial design intent while incorporating new methods to assist the rider.
The Voodoo Hub team is a subgroup in Velovations with currently 3 members, myself, Luke Rosinski, Austin, and Kobe. It was created 4 years ago after Tony Senger, a tech alumni and head of Senger Innovations, contacted Velovations for assistance with his new, patented spring balance roller clutch system. Since then, the Voodoo Hub team has assisted with generating models, simulations, prototypes, and comparison testing. Shown is the most up-to-date prototype that has been manufactured by our sponsor. How does a bike work? What makes it move? The specific device that transfers the pedaling force applied by the rider is translated to the tire through the rear hub located in the center of the wheel. The hub can have different designs, including pawl and ratchet, star ratchet, and sprag clutch. The most common bike hub is a ratchet design. It works by using pawls, which are mounted on the free wheel and spring-loaded to rotate outward into the ratchet teeth of the hub. The pawls are always in contact with the teeth. That is what causes the clicking sound when you ride a bike. The spring-balanced roller clutch system in the Senger Innovations Hub works when the rollers travel up the ramps and push the friction pads into the inner surface when the rider spins the hub. Inversely, this means that when the rider is not actively spinning the hub, there is no internal contact, meaning no noise or friction. The video demonstrates the engagement and disengagement. The key advantages of the Voodoo Hub, no friction and no sound, will be shown in our testing. During our testing last year, we discovered that many flaws in the test fixtures came up. Also, we were unable to use the same data acquisition equipment from previous semesters. Because of these challenges, we have been working to modify our test fixtures and data acquisition systems to better examine the Voodoo Hub traits compared to 4 other market-leading bicycle hubs. We have 2 fixtures, one for sound/drag, shown on the left, and the other for life cycle, shown on the right. After modifying these fixtures and the code used to run them, we ran tests and collected the data for the 5 hubs. We then compiled and compared the data. Shown are the data sets collected on the newly modified sound/drag test fixture. The first plot shows a comparison of the 5 hubs' sound versus RPM. Ambient noise is also plotted for reference. As you can see, the Senger Innovations Hub performs similarly with the other silent hub currently on the market, the Onyx. It is also important to note that both of these hubs are so silent that they wouldn't be noticeable over the sounds you would hear from riding a bike at moderate speeds. The second plot shows the comparison of RPM versus time for the 5 hubs. Lower amounts of internal drag results in longer coast times. As you can see, Senger Innovations Hub is leading the group. This is expected since when not engaged, there's no friction on the inside of the hub. The Senger Innovations Hub project will be concluding this semester due to prototype constraints. In the future, Senger Innovations will use the results we provided to continue developing the hub and attract new investors in hopes of the hub becoming a marketable and competitive product. Velovations is an enterprise open to exploring any projects that revolve around biking. We are proud of the work this year's 2 teams have done, and we look forward to what the future of Velovations has to offer. We look forward to seeing and speaking with you all at Design Expo. Thank you for taking the time to learn more about what we do here at Velovations.